At the edge of an international border, at the edge of the Pacific, at the edge of innovation, community, education, and discovery, you're listening to At the Edge of It All, a University of San Diego podcast where USD experts speak on topics and stories that impact you and the broader community.
Hi, I'm Cameron Zek.
And I'm Lisette Martinez, and on this episode of At the Edge of It All, we speak with Dr. Daniel López-Pérez, who is one of the co-founders of the architectural department here at the University of San Diego's College of Arts and Sciences, and he also has a very interesting housing project.
Yeah, it's called the Polyhaus. It's like a polyhedron design. It was put up in a matter of days, and he says it's going to solve San Diego's housing crisis, and it's also climate resilient. Let's take a listen.
Dr. López-Pérez, thank you so much for being here with us today. We want to get started by talking about where you grew up. I understand that you grew up in Spain for most of your childhood, but then moved to the U.S. when you were in middle school, correct?
Yeah, that's right.
Tell us about your upbringing.
That's right. Well, first of all, thank you for having me, and I really am a fan of your podcast. Yes, that's correct. So I'm originally from Spain. My mother is a painter. My father is an engineer. So that's a kind of cliche of architecture as a kind of an engineering art.
The perfect marriage.
Or an art, exactly. That's right. And I was very fortunate to live to be born in Spain. Spain has a very deep, long tradition of modern architecture. So it is always present. Our cities have public discourse with planning and with architects committing to the design of cities, the design of housing. So for me, it was a kind of a foundational opportunity to start to think about everything from housing. We lived when we were young in a very tall tower in an apartment. And then moving on to the periphery of the city. So for me, living in Spain was this foundational moment, right, where there's a kind of a larger discourse. Architecture is thought of in the public discourse, right? Yeah. And then we moved to Florida, and it's a completely different.
What a contrast!
Yeah. To Orlando, my father came with an American company that was starting nuclear energy, so he was working in that sector, and we lived in Orlando for a number of years, and then I went back to Spain to finish high school. Yeah.
So with a father who's an engineer and a mother who's an artist, I mean, growing up, was architecture something that you were immediately drawn to, or how did that kind of come about?
Yeah, that's correct. I mean, architecture for some of us is a vocation. So I never at any point thought, what am I going to study? I always knew I was an architect. And it's the cliche of, drawing things, already drawing structures when I was.
Did you do that a lot when you were little?
Yes, absolutely. Constantly drawing my entire childhood. Yeah. So I believe that in my case, it's a vocation. I never consider being anything else. Yeah.
Did your parents always support that?
Yes.
Like when you were little and said, wow, you were going to be an architect and
Yes.
we're going to help you along the way.
Yeah. And curiously, architecture is such a broad field that it allowed me to talk to my father in a very technical way and learn from him. And then it also allowed me to have a relationship with my mother in terms of her painting and us drawing together, going to drawing classes together. And that part of that more artistic side, having that balance. Yeah.
Wow.
So you're the founding faculty member of our architecture department here at USD. And when I was speaking with you a couple of weeks ago, you said one of the pivotal moments in your architecture career was competing in the World Trade Center competition. Can you tell me just like a little bit about that? What really sparked your interest after that competition?
Yeah, that's correct. So I started my undergraduate studies upstate New York, and then I finished them at the Architectural Association in London. And I then returned back to the US for my master's at Columbia, and it was 2001, and I started my master's program in September. It was 9/11. So being in New York in that context of absolute tragedy and then rebuilding, all of us were immediately committed to participating in whatever way we could. So at the end of our program in 2002, there was a gathering of teams for the Lower Manhattan Development Corporation, and we were curiously, many of the people in my program participated in different competing teams. There were 6 teams. I was part of United Architects, so a conglomerate of 6 or 7 firms, international firms, competing to design the scheme. Obviously, we did not win, But I was always drawn to the technological complexities of high-rise buildings and the technical dimension of architecture. Yeah.
You also mentioned that architects help society see into the future, right?
Yes.
What exactly does that mean, and how is that put into your work?
So we are very fortunate because we are a discipline that, like engineering and other, that we actually literally plan the future of the built environment, right? So that in the largest projects or to the smallest projects, architects foresee the future before it is built. They have that direct impact. And I always tell my students that you have that awesome responsibility and opportunity, right, to shape the built environment in unlikely ways, in ways that we've never seen before. And it is a remarkable thing because architecture is one of the oldest disciplines, right? So the built environment is shaped over centuries, and I guess you could argue even over millennia to be in a particular way, so that innovating in architecture, innovating in the built environment is, has that responsibility, has that history, and also has that need for technology, has that civic responsibility to all, everyone who inhabits spaces and built cities, right?
I wonder, in all your studies and research and work over the decades, what has surprised you the most about the field of architecture through time?
Well, it's there are many things. I mean, of course, architecture is this broad umbrella, this broad field that is responsible for its own history. We would be naive to think that all of us come from a place and are shaped by it, right? So the necessity to understand the history of where you come from and the place that you're acting upon. Then this entire dimension of technology, right? Architecture is, or the built environment, let's say in the broadest sense, and I'm talking about civil engineering, I'm talking about all of our allied fields, are highly complex objects, right? When we think about systems, when we think about transportation, when we think about buildings like hospitals or airports, right? These are highly technical objects, right? That have all kinds of technical responsibilities. And then we have to think about our architecture's civic responsibility, right? That actually the way we shape our cities is a political project that affect the way that people live. So I always stress to my students, the relationship between the individual and the state is shaped through the built environment. So the kind of housing options that we have, the suburbs that we build, these are political decisions that affect the entire community at large. So reconciling both history, technology, and that dimension of the public sphere, our public and political responsibility to creating just, affordable, clean, healthy cities, all comes into play, right?
And as you say, the culture and society aspect of things is so important. Just last night, I was with my son, and we were looking at some pictures that we came across online of different countries and cities and how they look from above.
Yes.
And it was so interesting to
Yes.
see the vast differences in countries
That's
and
absolutely
places,
right.
and how it was all kind of mapped out and what
That's-
it looked like.
That's absolutely, and we could trace from an airplane, right? There's a long modern tradition of the 20th century of planners getting for the first time on an airplane and gaining a kind of a holistic view of the geometry of cities and how some of them are very functional and grid-like, others are very ceremonial, so they're rings around different monuments, and that literally it's awesome and a great opportunity to think, how do these geometries really organize our society in better and more productive ways? Yeah.
Right.
And you mentioned, seeing into the future, having innovative design, adapting to
Yeah.
the areas where you live. And you are doing all of this right now with
Yes.
your Polyhaus project, which is
Yeah.
super cool. I've seen it in person. It's like it makes me feel like I'm at a modern cabin, all exposed wood on the inside, really futuristic looking. So for those who haven't seen it, tell us a little bit about what is the Polyhaus, and I guess if you can describe it visually as much as possible, because it's really cool.
Yeah. So let me just go back a little bit about your question about founding the architecture program at the University of San Diego. So back in 2000, I come to USD in 2009, and in 2010, along with a number of colleagues, we were all together. We founded the first program out of the 3 main campuses. We're the only architecture program in the 3 big campuses in San Diego. And immediately, we wanted to unfold our program into the questions that exist in the world. So it's very important that our design studios are grounded in problems that the city of San Diego has, challenges, opportunities. And so inevitably, in the last 15 years, we were drawn and asked to work on the question of housing. I mean, forefront, that has been a kind of a challenge, not only in California, but now at a national level. So we had the opportunity to work really closely with the city. So that opportunity of both understanding the question of housing and that problem across all of its typologies. So we have done with the students, we have reimagined golf courses turned into housing. We have put housing in unlikely places. We have reimagined industrial lots that have now been turned into housing. So finding housing, finding fair housing, finding the technology to build affordable housing is such a complex and awesome problem. We dedicate upper division, every semester we dedicate upper division studios to the question of housing. It is a foundational question in our discipline. So in this research here on campus, in my professional practice, I begin to think about opportunities to innovate within the housing space. We have the entire deregulation of single-family zoning in order to find out opportunities to build more density within our urban infill and within existing houses. So I zoom into the question of accessory dwelling units, but then think about a system of housing that is resilient enough that can be replicated, right? That has the possibility of being flexible, but at the same time responsive, but at the same time has the efficiencies of a system. So Polyhaus is born out of a mission to accelerate housing production. It identifies a series of proven technologies that are revolutionizing our field at much, much, much larger buildings, like mass timber, cross-laminated timber. These are robotically fabricated and robotically milled wood panels, right, that are now beginning to transform much larger buildings, replace concrete. So I speculated about the possibility of, can these proven technologies be brought to the residential scale, the smallest scale, to urban infill lots of under 20 units? When we think back about our housing production, we are still building houses 1 2x4 at a time. Mm-hmm. So when we think about labor, when we think about our local builders and our local general contractors, the immense amount of labor that goes into building houses 1 2x4 at a time, or building 500 square feet with, it's literally 8 to 10,000 2x4s. There's got to be a better way, right? So what Polyhaus does is it identifies these technologies, brings them to this to that small scale, residential scale, and then it puts forth a system, right? So that working in conjunction very closely with the city of San Diego, we're able to permit and have that permit be used on multiple sites. We're able to conceive of the idea that unit number 1 is improved when we build unit number 2 and unit number 3 and unit number 4. That kind of systemic thinking. Right now, we are building one 500 square foot structure at a time, and they're all different. So if from the planning side, from the review side, from the technological side, we're never going to get to scale if we don't reimagine the way that we build the houses. And so Polyhaus was this opportunity to do that technologically with the mass timber, And then in terms of logistically, in terms of planning with this idea that you reference permits and the city doesn't have to review things that they've reviewed in the past, right? That we bring this systems thinking to the smallest scale.
Another big part of the Polyhaus, obviously the issue of housing is one, but climate and how that is affecting our areas is another.
That is correct.
Everyone knows that California, unfortunately, burns almost every year.
That is
There's
correct.
always some part of California that is affected by fires, and other parts of the United States and the world. Talk to us specifically about how the Polyhaus answers this situation.
That is correct. So one of the most exciting things about mass timber, and this is cross-laminated timber, and it's a really new technology, right? About a decade old, but it uses wood, which is the most ancient material, right? One of the most fascinating things about mass timber is that it builds a direct connection with our forest. Our forests need to be reharvested. They need our help. Some estimate that they need to be reharvested. 40% of their extension needs to be reharvested for them not to grow to 100% and cause these catastrophic wildfires. Mills all over the U.S. work very closely with the federal government and the Federal Forest Service to do these reforestation efforts. So these are efforts that are already in play. And it's a very intricate process. You have to go into the forest. It's about distances of trees. It's about species. It's about keeping the forest safe. So what is exciting about Polyhaus is that it builds this direct connection between the health of our forest and housing production, quite literally. So that as these panels of mass timber are being produced, so for instance, Polyhaus works with Wagon Timbers in Washington State. Wagon Timbers reforests through their A to Z forest to frame project. They reforest the Collier Forest. So this is a very large federal forest that is half in the U.S., half in Canada. So that there is a direct connection between what our structures are made out of and the health of our forest, right? So if we begin to build industrialized systems by which we think back, what are our buildings made out of, right? And how do they contribute to climate resiliency and to keeping our forests? It's a really extraordinary opportunity.
So really, the Polyhaus wouldn't burn at the same rate as a regular home?
So that's the thing. The mass timber is, so imagine it is like plywood where every layer is about 1.5 inches. So these are very massive in terms, they call them mass timber, right? They're about 3 ply. They always work in odd numbers. So that it's a game of cross laminating the grain of the wood for it to gain its rigidity. It's robotically manufactured to not have any air cavities in the panel. And then once the panel is up, they're 4.5, they range from 4.5 to about 7 inches thick. They weigh somewhere between 800 to 1,000 pounds per panel. Because there's no oxygen, because there's no air cavity, the burn rate is 6, 7, 8 times what would be with conventional timber frame construction, where we have 2x4s and we have air cavities in the middle. So their kind of resiliency to fire is extraordinary, right?
And then one last question in regards, because I know Cameron wants to ask you some other things, but like, what does this mean when you talk about building the pre-manufactured type of structures for the construction industry? Like some people would say, oh, is this gonna end jobs for construction folks, or
yes,
what does this mean
that's
for the labor
thing.
force?
So we are very excited. So the reduction in labor, it is not about reducing jobs. It is not about reducing labor per se. It is about empowering local builders and local general contractors to just simply build more units faster. Our local builders and local general contractors, when you're talking about the residential market of, let's say, 20 units and below, when you're talking about apartment buildings of 60 units and up, these are highly industrialized sites, highly efficient correlation of trades, plumbing, electrical. These are all very organized. But when you're talking about the residential urban infill market of, let's say, approximately 20 units and below, all of that industrialization is not available, right? And our general contractors and our local builders do not have the time or the means by which to do research into technology. They don't often have new methods of construction available to them. So where Polyhaus comes in is it empowers local builders and local general contractors to simply build more units faster. So rather than building maybe 10 units a year, you're able to build 20 units a year for the same amount of time and gaining the efficiency of these highly industrialized materials, right? So it is a project of really empowering our labor, our local labor, to just build more.
And one of the cool things when I saw the Polyhaus, and you kind of went into it, so it's panels of, and it's what, 60, how many panels
60
is
panels,
in that?
yeah, 60
that
panels.
Okay, perfect. So it's 60 panels, and it's kind of put together like a jigsaw puzzle,
Yes.
and you can even use an app. So the
Yes.
people who put it together had never
Yes.
seen it before and used an app, and it's like, putting together like a puzzle.
That is
I'm
correct.
curious, what did your students think when they came and saw this, the final product? What do they think, and why do you think it's important to be teaching them these like emerging technologies like this?
So for us, for me, for me, it is a privilege to work with our students, conceiving the edges of our discipline, both with respect to technology, really studying across time, let's say 100 years of people trying to innovate. So the idea of a house being carried on a truck is about 100 years old, right? The idea of a house made out of only aluminum as a way to, in the post-war period, we had a lot of architects imagining, okay, we have all these airplane factories that have built all these airplanes for the world wars, and now we don't need them anymore. Can they begin to build houses out of aluminum, right? So the edge of our discipline with respect to technology is a really fertile field. And for me, it is a privilege to be able to have identified this new technology on mass timber, robotically fabricated, and to be able to show our students literally that even in your own backyard, you are able to conceive of this project and carry it through and be the first, right, at this scale to build this diaphragm made out of mass timber. It did go up in 3 days. The entire rest of the trades can complete a unit in about somewhere between 8 to 12 weeks. So it is in terms of weeks, not months, that we're talking about. So for me, it is a privilege to show students in my professional practice that the edges of our discipline are available to be met and to be reimagined, right? And then build that knowledge base with them. Yeah, absolutely. They did see the project go up on site. They did see and we study this technology theoretically and in much larger projects in other places, in our classroom, in our seminars. And now we literally see that these prototypes can actually be carried through. Yeah.
Well, we'll add a description to the podcast information so that they can see this great house in action that you put together in like 3 days, you said, right?
Yeah. But the structural frame, then the rest of the unit is complete in about 8 weeks. Yeah.
And lastly, are there any drawbacks or obstacles or setbacks to doing something like this that you have been able to come across? Or
there are all kinds of challenges. Obviously, when one is innovating and has a prototype that is unprecedented, there are challenges with respect to, zoning or like development services, or a city trying to understand what's the nature of the project. Homeowners insurance sector saying, how would we insure something that is new, for instance? We're very fortunate that in the realm of architecture or the built environment, the state of California leads the world with standards. So the state of California has the most rigorous building code, I believe, in the world, and we have the strictest. So every material that is built in the state of California goes through incredibly rigorous testing for it to be not only technologically resilient, but also climatic resilient. So we're constantly, we are constantly assessing the way that we build our built environment, and obviously that is a double-edged sword, right? Because you have at the end so much legislation that goes into making sure that our buildings are so so resilient and so climate respondent, and so that at the end, sometimes all of those processes end up costing more money, and that at the end, all of those due diligence layers of due diligence end up costing more, right? So we're constantly measuring legislation to production, right? So I would say that's one of the, in terms of innovating, every time you do anything new, all of these concerns come into play, but at the end, mass timber is a standard construction method. It is not outside of the code, it is not outside of, and it has taken these very large suppliers many, many years of testing to get it to the California code. And so I would say those are some of the challenges. For me, if I zoom out, and yours is such a good question because we're constantly assessing what we do, right? The price of innovation to the price of just doing business as usual, right? Continuing to live in the cities that we have as they are. And now increasingly more, we are coming into consciousness that we cannot, right? Due to catastrophic wildfires, catastrophic landslides, catastrophic rain events. So what is the cost of, and at the end, there is one primary mission to Polyhaus is to bring these technologies at this scale affordably. So everything is off the table if what we're imagining, if these technologies are not able to be affordable, right? To be able to be afforded to the maximum number of people. And I know that the question of housing at the national level is centered on the question of affordability, because otherwise there is no system, there is no production. So our mission starts accelerating the housing production in the housing space starts with having these things be affordable. And when you transplant these very large industrial technologies that are built in thousands and thousands of panels, for instance, the insulator metal panels, these things are manufactured to cover entire commercial buildings or institutional buildings. And when you bring them down to the smallest scale, how do you overcome the cost factor? And so working in partnership with the entire supply line is not easy. And that is part of the challenges that any system has. How does one start a system knowing that perhaps the first 100 units are going to, be challenged in terms of their price and be able to then gain scale, right? So in Polyhaus, our mission was always to match conventional construction prices. We've achieved it in the prototype unit, and we are bullish about the idea that if you tap into a system that has 5 years of engineering, you benefit from that. So unit number 2 benefits from unit number 1, unit number 100 benefits from, and you add intelligence to the system, right? But it starts out with affordability, absolutely.
Well, how exciting that we have architects such as yourself and your students here at USC, and quite frankly, all around the world, thinking about these big problems and these big solutions. And, I'm just really excited to hear you speak and to watch what you are doing here at the university.
For me, it is an absolute honor to be in this program and to work alongside our students, reimagining. We have students that go into public service and work for cities. We have students that go into this civil engineering sector and work on infrastructure projects. We have students that work on office, in development per se. And then we have students that go and work in architecture firms, and that whole breadth, that wide breadth, and that goes back to our kind of a liberal arts core, that you have this larger understanding of architecture. It is such a privilege, and it allows us to, whereas before maybe we were able to not have a true understanding of the repercussions of our built environment. Now we do. Now we have to constantly think about it and constantly work at improving it. And architecture is at the forefront of that.
Yeah, well, I was going to say the most important part about this whole thing is, in any discipline like engineering or anything else, law, medicine, is that it's centered in the human experience, right?
Absolutely.
Otherwise, none of this really matters.
Absolutely. And I tell my students, architecture and even housing was one out of 3 themes in the last presidential election. You were at the forefront of government and of our states and our cities being able to manage themselves, being able to manage all of us that live in these cities, and so there's a greater collective project that, you're right, has to do with service. And things that maybe 2 or 3 decades ago we could afford not to think about them, now we have to think about the way that our buildings are built. How are they built? How are they related to climate and sustainability and resilience and all of these things, for sure.
Well, Daniel, thanks so much for joining us today on the podcast and sharing your story with us. And if you like this episode, be sure to subscribe to catch our next one.